Alright, hello everyone. So let's discuss our second case here, when the power of tangent function is odd. Alright, so we have, for example, here tangent cube times secant cube to integrate. Okay, so the fact that we need here right now is the derivative of secant. What is the derivative of secant? Derivative of secant is actually secant times tangent. Now can you think what will be our procedure? Or what will be our u? Remember, we choose our substitute so that we can cancel out the function that we split, right? So here my substitute will be secant x. If my substitute is secant x, what can you split here from the integral? What should you split? If you want to cancel out certain terms, well, we can split out both a secant term and a tangent term. See what happens. So if I split a tangent term from tangent cube, which will become tangent square, and I split out a secant from a secant cube, which will become secant square, then I split out tangent and secant, right? And then if my substitute u is secant, then derivative of secant is secant x tangent x. We already know this. Dx is then du over secant x tangent x, right? Okay, so let's do the integration by substitution. All right, so let me make some space here. So here then this is tangent square x secant square x, okay, and then we have tangent x secant x. Okay, why am I writing this again? Okay, so let's replace du over secant x. Okay, this is secant x, secant x tangent x. So secant x and tangent x cancel out, right? U is secant, so this should be u square, right? All right, so this is what we have. As you can see, if we choose our u to be secant, okay, then we can split out secant and tangent. Okay, all right, so then secant and tangent cancel out, again maintaining that relationship. So what we have here is to integrate u times tangent square x du. Now we cannot afford to have x terms here because our integral is in terms of u. You are integrating in terms of u. So how can you get rid of tangent square? We use the Pythagorean identity, right? That's what we do when we have excess terms in these odd power cases. Alright, so Pythagorean identity is 1 plus tangent square is secant square. So tangent square is actually secant square minus 1, right? Secant square x minus 1. So secant square x is u, so u square minus 1 is tangent. So u square times u square minus 1 du. So if you distribute u square, you will have u to the 4 minus u square du. So if you integrate this, what you get is u to the 5 over 5 minus u to the cube over 3 plus c. So u is secant, and you can replace u by secant and write the final answer. But here's the summary. So when you have an odd power for tangent, okay, odd power for tangent, we split both secant and tangent. When you split both secant and tangent, we use our secant to be substitute, because derivative of secant is secant times tangent, so that you can cancel out both of these terms. Okay, now here's my question. Can we do that when you have an even power for tangent? Try to do it by yourself and see what happens. Try to do this split for like tangent square x secant square x or secant cube x, doesn't matter. Try to split both secant and tangent, okay, and try to use the substitute u to be secant. Okay, and you will be able to cancel out secant and tangent and see what happens. See where is the struggle. Okay, you will see all this. You will see cancellation and you will get an excess term. Think how can you get rid of excess term, and that's where the trouble comes. Okay, try to see what you get and try to integrate what you get. That's where the trouble comes. Okay, that's why we can't use the, you will see why we can't use this particular setup when you have an even power for tangent. We can do this particular process if we have and odd power for tangent. Okay, all right, so that's it for this video. In next video I'm gonna solve multiple problems from this strategy and the strategy that we learned in the last video. Okay, all right, thank you very much for watching this video. Bye bye.